section and flight path angle equation, which is these equations. And we have done is QBO less than 1. So this is done. And now we're going to talk about these situations when Q equal to 1. So under this situation, when Q equal to 1, then basically this one will plug in here. Basically, Q minus Q and divided by Q simply equal to 1. So what we have is this one. Okay. So this situation is pretty much straightforward. So in this way, actually, we know this side, and for any angle, this one is also equal to sine times pi minus v ff over 2. Okay, because we know for any sine theta, so say if this is a theta here, then the other value we have the pi minus theta. So for the two different angles will give us the same numbers. So basically, once we have this, in value we could also have this. Okay, so that means here, let me say this is or this. Okay, so compared to this one, you can see that pretty much straightforward. 5PO plus VFF over 2 equal to VFF over 2 or pi minus VFF over 2. So therefore the VBO will be equal to two values, either 0 or pi over 2 minus VFF over 2. Okay, so this case it will be more straightforward. So we studied the possibilities. So under these situations, then we can see so here is our solutions here, and we see what happens for say VFF is less than is within the 180 degrees, and I want to discuss when VFF is less in this range, we see what happens. So this is VBO. Okay, so I simply split it into two ranges. So once the VFF is less than 180 degrees, then here we have two values, degrees or numbers. So if the V is less than 180 degrees, then that is or positive numbers. Okay, so that means, and here we have the 0, so if this is the Earth, and this is the burnout, so this is the local horizon. So either you would have top options is either you have when Q equal to 1, then you have the possible solution, and that is V, or the other possible solution is this. So let me say this is V, and this is V. So for this case, its corresponding is VBO equal to 0, and for this case, that corresponding is VBO greater than 0. Okay. So basically here we have two feasible solutions for VBO. And then we see the other case. And for this case, when, again, for the VBO, we have 0 degrees, and that is from our the first equation here. The second one, you can see when the side is greater than 180 degrees, then basically this one is or negative value. We see what happens. So if this is the Earth, I think I need to draw a whole thing here. So this is center here. Okay. So for example, if this is our burnout point, And right now, this is the free flight. And from here, for this case, we want to achieve a flight path the flight range angle 180 degrees. So that means here, that one we're going to try is here. So we asking for this situation is the free flight angle is greater than 180 degrees is this situations. Okay, so now for this case, you can see the only way we can try is this. Either you have to do it in 0 degrees, so that means you have to do in this way. So basically that is the 0 degrees. Okay, so that is a 0 degrees. So corresponding, this is 0 degrees. The other theoretical solution we suggest is negative. So negative, that means here, if you're going to do the negative, that is in this way. The path for this will be something going to dig into the earth, not practical. Okay, so for this case, I can tell you is only have EBO only has one feasible solutions, which is VBO equal to 0 degrees. Okay. So that is for this. So that's it.